Hello everyone, it's Benny, and as you may know, I've recently joined the RDF, so I thought I'd just share a couple of things I built while I've been on the RDF server. And first up is this ALU. Now, as you may know, I built a 5-tick ALU not long ago. I managed to shave off a tick. It's 4-tick ALU, doesn't have the hack in it anymore, it's 4 ticks, and it's pretty amazing. I'm really happy with this thing. So, it does pretty much everything you could possibly want. You can set A to 1, set B to 1, invert A, invert B, disable carry, yada yada, carry, blah blah blah. You know, all the usual things you could do with any big AOU that could do anything. It also has an integrated comparator, which I think is pretty cool. So, no separate comparison unit, it's completely integrated into the AOU. And yeah. So, I like this thing, I'm pretty happy with it. And moving on. Okay, this is something I built when I was testing out CPU architectures. It's a CPU based on the Hack computing platform, and I like this thing. I built this mostly just to see how the platform would work out, and really, I'm quite pleased with the CPU platform as a whole. It's very powerful, it's very simple, but it's extremely powerful. You can do pretty much anything you could ever want with it. This is my first rendition of it, purely to test the platform. It's, as a result, incredibly slow. I paid pretty much no attention to speed. This thing's about 50 ticks, but I could easily build something that's about a little over 10 ticks and it would be about the same size, so yeah. I really like this thing, even though it is ridiculously slow, but yeah, it's given me a good idea of what the Hack platform as a whole does, and I like it, so yeah. And if you don't know, the Hack platform, well, actually you should look it up. I'm trying to keep these things short because I have a lot of things to cover and not a lot of time to do it. So anyways, moving on. Okay, this thing, it's a BCD decoder. It converts any binary number into binary coded decimal, which is essentially something that's really easy to take for 7-segment displays to take in and convert. So what should I put in? Oh, I'll just put in max number, 65,536. It's 16-bit, so just put in max number. And this thing is 69 ticks. It's fairly fast, although I can make it a whole bunch faster if I really wanted to, but yeah. So I'll just let you see it work. And come on, hurry up and get over to the end. And there you go. So let's activate. And in about 8 seconds, we'll have the display of potentially the max number. We'll see. And 65,535. There we go. That is 15 ones in binary, and yeah. So, moving on. Okay, this right here is me playing around with real-life addition algorithms. This uses the Ladner-Fisher algorithm. It's extremely fast in Minecraft. This is a 7-tick adder for 8 bits, and it uses absolutely no pistons whatsoever. So just to prove, I'm pretty sure it's... yeah. Carries over to the 7th bit in 7 ticks. Really fast, and I really like this thing, so yeah. And that's pretty much going to be the story for most of these things, but anyways, moving on. Okay, this is a 5-tick comparator, also made without pistons. And actually there's a slight bug in this thing right now, which makes it 6 ticks in one case, but that's a bug and it can be fixed easily. I'm just really lazy, so yeah. But it will be 5 ticks if I decide to remove that bug and not be lazy. But yeah, so that's right now it's A is equal to B. If I set A to something higher than B, it says A is greater than B. If I set A to B higher all of a sudden, A is less than B, and if I make them back out to the same thing, it's back to A is equal to B. Comparator, very simple, it's amazing. Okay, this thing. This is a pretty big thing, but I'm really like this. It's a floating point adder. If you don't know what floating point is, well, I really don't have enough time to explain it in this video without making it really long, but essentially it's a way of, instead of using the bits as normal binary numbers, it's almost like using them like scientific notation, and it allows you to represent really big or really small numbers in the same number of bits. So this is a 7-bit floating point adder, and I can add some numbers with this, but I really don't think I have enough time, but yeah, it's pretty cool. I have no idea how fast it is, but if I ever actually build one, I'm going to redo this. But yeah, still, it's kind of cool, it does floating point addition, and yeah, moving on. Okay, this right here is something I'm sure a lot of you have been wanting me to do for a very long time. it's a divider. One that does actual division, none of that really only works with certain numbers type of division. It's a divider that works with any number, and it's pretty cool, in my opinion. It's mostly aimed at being small in this case, but... So yeah, it's kind of slow, but it's still pretty cool. It works, and I like it. The only thing is I've been too lazy to actually hook up some control logic right here, so you kind of have to manually decide when the division is over. So yeah, it's kind of buggy in that sense, and actually, why not? I'll divide something. So right now I have in... I believe that's... Is that 8, I believe? No, that's 4, okay. I'll divide 4 by 3. And if I actually have 4 divided by 2, I'll divide 4 by 3. And actually, you know what, why not? Let's make it more interesting. Let's make it 11 divided by 3. Okay, and if I can shut this thing off at the right time, we should get the correct answer. So let's just run. And that should have been the right time, so it's given us 3 right there. So 11 divided by 3 is 3, with a remainder of... Okay, I did not shut it off at the right time. Oh well. If I shut it off at the right time, this would have been at 2, but, you know, yeah. If I had the control logic, that wouldn't be an issue. But anyways, I thought you might find that interesting. So yeah, moving on. Okay, now this is something that's actually pretty cool. This is an adder that uses my own addition algorithm that's modified based on the Kagi Stone addition algorithm. Completely pistonless and 4 ticks. And it's amazing. If I hit this, boom, boom. 4 ticks, no carried propagation delay. It's amazing. The only problem with this algorithm is the wiring gets kind of congested. So it's not exactly the most practical algorithm, but if you can get all the wiring right, then this will be 5 ticks no matter how many bits you put in. The only reason I have it 4 ticks because I managed to do a sort of a trick, I guess you could say, that shaved off an extra tick, but in most cases it's 5 ticks, and it works for any amount of inputs, and it involves no pistons at all. So pretty neat in my opinion, and yeah. I'll talk more about this when I talk about addition and Ultimate Guide to Redstone, but yeah, moving on. Okay, now this giant thing, this is a multiplier. It's also using my own particular algorithm, and this is really mostly experimental, but if this thing was using an optimized version of my algorithm with optimal hardware and stuff, this should be about 15 ticks, but right now I'm just using it for proof that the algorithm works, so it's about 20 ticks. Still, that's pretty fast for a multiplier. And why am I getting 4 ones? This should not be happening. Okay, that's very interesting. I think someone might have been screwing with my multiplier earlier, because that should not be happening. Okay, let's figure out why this thing's not working. Okay, that should be... Why are you not going up this ladder? This is very strange. Okay, apparently some of my wiring has decided it magically does not want to be there. So, okay, now it should be doing 15 times 15 as soon as I flip the lever. So it takes 6 ticks for the signal to actually reach there, but yeah. After that, it should take 20 ticks to actually do the multiplication. So that bit's extended, that means the input's reached. And I'm still missing some wiring somewhere. Okay, whatever. Trust me, it does work. I've used it before. This thing works. It's just missing some wiring in some elusive location where it's actually right there. And now that should be giving me the correct answer. Okay, it's just decided to randomly lose some wiring for some reason, but the whole thing works. Trust me, I've used it before all the wiring decided to go missing, and it works. So yeah, moving on. Now this is something I just built for fun. It's a 2-tick pistonless half adder, which is a deceptively difficult thing to do, but yeah, pretty cool. 2-tick pistonless half adder. And yeah, there's the and there's the XOR. I like it, and yeah, moving on. This is something that's kind of cool. It's a ripple carry adder, so essentially the slowest algorithm there is, but on the rising edge, it is 8 ticks, but only on the rising edge. So if I hit this, you notice that those pistons retract at the same time. 8 ticks on rising edge. On falling edge, though, much slower. So, yeah. But still, pretty neat. And yeah, moving on. Now, this is something that's actually really cool. It's a stack machine. Essentially what this does is it lets you save information, and every time you save, instead of overwriting the previous information, it just keeps saving. So you can store a whole bunch of information with a single save command. And then that's called pushing to the stack, and when you read from the stack, it'll just delete the previous information and read the other information. I'm going to explain more of this at some other point, but right now, just thought I'd show it to you. So, I'll save a 3, I guess, why not? And right now, it should be saving, so if I hit this, it should have saved a 3. And as you can see, there's a 3. If I save again, it saved another 3, so good. And now let's read it back out. So right now it's reading a 3. If I hit this, it'll read back to the other 3. So now, it's deleted that 3, now it's the other 3. I should have put in something else so it's not as confusing. Now let's save a 5, why not? So now I'm going to save a 5 to the stack machine. And now, I'm back on 5. If I go back to reading, I read, which is popping, there's a 3, and if I read again, it should go back to 0. Yeah. Again, don't have too much time to explain how these things work in depth, at least I'd like to, but this thing's really cool. It can be used for a whole bunch of different things, and I'm about to show you one of those things right now. Okay, so this giant screen right here, it's a word processor. So right now it has some stuff typed in it, but that doesn't matter. We're going to input some characters. I didn't actually do a character input system because I was too lazy, but we can type something, so I'm going to type in A, and now if I type, then that should type an A next to my cursor, just like a real word processor. So now I should have an A. Okay, if I want to, now I can type a B. And if I move over here, it's going really slow, but that's just me moving, so if I change, if I go 2, that should be B, type, and now we should have AB. A, B, good. Now I can insert characters next to it, so just like real word processing, so I don't have to type, I can actually insert characters. So I can insert a B next to it, so I'll insert a B next to the cursor, not typing it. So, now I have a B next to the cursor, and one of my displays derped, but that's okay. So there. If I don't want that, I can delete it, which is what I'm going to do right now. So, delete character. And there. That's gotten rid of the extra B, move that back over. So, I think it's pretty cool. And just to show the rest of the commands off, I can move left. And which way's left? I've over right and left. I'm pretty sure that this is the way I want to move right. So I want to move right. That's moving the cursor, which essentially should be shifting all the text over. And it derped because that someone had the luxury of playing with this thing earlier and decided to screw everything up. Oh well. It was working before. Unfortunately, someone derped it. Well done. Oh wait, you know why that didn't work? Because I was typing a B at the same time. That was my fault. So now if I move the cursor left, now it should actually work. Yeah, there you go. So despite my derp right there, where I accidentally typed a B in place of the space, it's working. So now, yeah, and just to show you backspace, because that's the last command. Backspace, where are you? Haha. I should delete that B. And now we should just have A. Yeah, now A, B, Capone. So there. That's all that. And yeah, moving on again. This is a 2-tick adder, like before, but it's too wide, and it's also conditional. The reason it's conditional is because it's impossible to make a true 2-tick adder in a too wide space, at least without using some buds or some control lines, and I'm not a big fan of those. Well, buds aren't the issue, it's really just control lines, because that way it makes it less practical. But anyways, this is a 2-tick adder. It's pretty amazing, I'm happy with it. And like I said, it's conditional. It only works if you put in A first. So I'm going to add 5 plus 3. That'll give me 8. It's 2 ticks, lightning fast, and unlike my other one, there's no flashing. So yeah, I like this thing. It's amazing. That's the story for most of my things. I don't create them if I don't really want to, but yeah. Only issue is it can sometimes cause dirt pistons because of this repeater right there, but I actually found a solution to that. I've just haven't made a 2-tick adder with that yet. But yeah, anyways, moving on again. And I have to show you this thing. Even, it's stupid, but it's amazing. This is a sequential adder, also known as the most inefficient adder possible. Sequential logic is a type of logic I'm going to talk about at some point, but essentially this adder's adding based on a clock. There's only one actual adder in it, and it's doing 8-bit addition based on doing addition with that one adder and saving the outputs and then figuring out what it needs to do from there. Incredibly slow, but it's a neat method of addition, and at some point I'm going to make a hopefully an arbitrary precision adder, where essentially you can add numbers as large as you want regardless of the number of bits you have, using the same technique. But as for now, it's just an example of a ridiculously slow adder. So if I start adding, as you can see, it's adding really, really slowly. And you get to see the bits shift down. And there's your answer. But yeah, still neat piece of logic. And yeah, this is another cool thing. It's a carry look everywhere adder, CLE. 8 bits, 6 ticks, no pistons, except for my test mechanism. But yeah, so if I add, everything turns off. It's completely synchronized, so outputs are completely in sync. That's one neat thing about it. And it's 8 ticks, or excuse me, 6 ticks, regardless of the number of, regardless. So really, really fast for non-instant carry adder. It uses no pistons. And carry look everywhere is an addition algorithm that was created by, I believe, Guy123456789 and Human Echo Rocks, I believe. And yeah, this is a 16-bit version. Unfortunately, this one has to be 9 ticks just because of signal length issues, but still, really, really cool, really, really fast, and I'm happy with it. So yeah, and this is just something neat I came up with. It's a, oops, that's the wrong one. This is a 2x4x17 pistonless dual read RAM. I'm pretty sure this is as small as you can get pistonless dual read RAM, and I'm also not sure if anyone ever did pistonless dual read RAM before this, but yeah, it's pretty neat. It's 6 ticks for data to travel all the way through, and it's 2-tick read for one and 1-tick read for the other, so yeah. It's all based on this right here, dual read mechanism, which fits in too wide space, and I'm really happy with it. And this, just for the fun of it, I made a triple read memory. This was actually because someone was making Yahtzee, and they needed this. So I made 2x4x26 triple read pistonless RAM, and it's pretty neat. Just for fun, I made a giant array of the dual read RAM, not the triple read RAM. And it fits nicely, pretty small, and yeah. This is something where I sort of observed an interesting phenomenon. It's a ripple carry adder, but its speed is n plus 3, where n is the number of bits. So 8 bits would be 11 ticks, 16 bits would be 19 ticks, 32 bits would be 35 ticks. Very interesting phenomenon, but it's still pretty cool. It's on both edges, unlike my other ripple carry adder. So, yeah, pretty neat thing, and I like it because it's small. But yeah, anyways, moving on. And I'll finish with this. It's a 3.5 tick instant carry adder. It's not the fastest adder, but the thing is, it, to my knowledge, is impossible for this thing to derp. and it's pretty small. And by derp I mean get double-headed pistons. So, yeah. I've yet to manage to get it to give a double-headed piston. It will block drop if you make it go fast enough, and it unfortunately does have a little bit of issue. Oh, apparently it doesn't, but it used to have some issue with that. I'm not sure what changed, but yeah. So anyways, this is pretty much everything I've done so far. I'm pretty happy with what I've done. Yeah. The RDF has really improved my redstone skill. I'm hoping to build some more things, particularly with the CPU type stuff. I want to build more CPU stuff, I want to build more BCD stuff, I want to build an even smaller and faster BCD decoder, because I know it's possible. Also looking for a really fast and powerful CPU design, and word processor, and they can get rid of that thing. That thing's just taking up space on my plot. I probably will get rid of it at some point, but yeah, still kind of cool. Gonna try to build faster mathematical circuitry. I'm interested in building a differentiator at some point, which would basically be doing calculus with redstone, which I think will be pretty amazing. So yeah, I already have plans for all these things. I already know how to do most of them, just a matter of time before I do it. And yeah, I'll be doing tutorials on most of the stuff I've shown you in this video, particularly the multipliers and dividers and all the different adders. So yeah, hope you enjoyed, and if you have questions about anything, or if you like seeing what I build and want to see more stuff I build more of the time, let me know. Maybe I'll do more videos like this, hopefully with fewer things and more in depth, so you can at least not just see it, and understand a bit of what's going on. But yeah, anyways, hope you enjoyed, and see you next time. And I forgot to mention, if you ever want to visit me on the RDF, I'm on there pretty frequently. You can just go to mc.therdf.net, log on to that server, it's open, anyone can join, and you can just do /warp_Benny to get to my plot, and you can see all this stuff firsthand. If you want to join the RDF, you can go to theردf.net and you can apply there. It has all the information you'll ever need. It's a really cool server. And yeah, so anyways,